November 18th, 1942. Somewhere over occupied France at 23,000 feet, Bombardier Lieutenant Robert Mathews, hunched over the most expensive secret weapon in American military history, watching his target slide through the crosshairs of his Norden Bombsight for the third time in as many minutes. The Saint Naz aire U-boat pens lay below, a massive concrete fortress that intelligence said was critical to Germany's Atlantic submarine campaign. The bombsight's analog computer had calculated the release point with mechanical precision. The gyroscopes held steady. The automatic pilot, slaved to the sight, guided the B-17 with inhuman accuracy. Every technical specification promised that Mathews could drop his bombs into a barrel from this altitude. The Navy brass had said so during demonstrations. The Air Corps instructors had repeated it during training. Carl Norden himself, the device's brilliant and difficult inventor, had wagered his reputation on it. Mathews released the bombs. Through the bombsight's 20-power telescope, he watched 8 500-pound bombs tumble away from the fortress, carrying with them 9 years of development, over $1 billion in investment, and the entire strategic bombing doctrine of the United States Army Air Forces. The bombs disappeared into the haze. Post-mission reconnaissance would later show them scattered across empty dockyards and residential neighborhoods, some falling more than half a mile from their intended impact points. The massive U-boat pens remained untouched. This was not supposed to happen. The Norden Bombsight represented American technological superiority made tangible. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. It was supposed to revolutionize aerial warfare, make strategic bombing militarily effective and morally defensible, and prove that American ingenuity could win wars without the mass slaughter of the trenches. Instead, in the cold reality of combat over Europe during the winter of 1942, it was failing spectacularly. What the bombardiers didn't know yet, what the brass wouldn't fully admit for months, was that the most sophisticated bombsight ever created couldn't overcome fundamental physics that made precision bombing from extreme altitude nearly impossible. The Germans knew it. The British had learned it through painful experience during their night bombing campaign. But American war planners had convinced themselves that superior technology could solve any problem. The collision between that technological faith and battlefield reality would force the 8th Air Force to abandon nearly every assumption about how strategic bombing should work. The Norden wouldn't fail because of engineering flaws. It would fail because the entire doctrine built around it rested on conditions that existed only in controlled tests and propaganda films. But before anyone understood that, the bombsight had to be built. And before it could be built, one stubborn Dutch engineer had to convince the US Navy that he could solve a problem that had frustrated military planners since the first pilot dropped the first bomb from the first airplane. Carl Lucas Norden was born in Semarang, Java, in 1880, the son of a prosperous Dutch merchant. When his father died 5 years later, his mother moved the family back to the Netherlands, where Norden received a rigorous technical education that emphasized precision and perfectionism. He studied mechanical engineering at the Federal Polytechnic Institute in Zurich, graduating in 1904 with skills that would prove ideally suited for the emerging field of precision instruments. Norden emigrated to the United States that same year, arriving in a country that was just beginning to realize the military potential of powered flight. The Wright brothers had made their first flight only 1 year earlier. Aircraft were fragile curiosities, not weapons. But Norden possessed the ability to look at nascent technologies and imagine sophisticated applications years before anyone else could. He found work with Elmer Sperry's company, developing gyrostabilizers for Navy ships. The partnership was rocky from the start. Sperry disliked Norden's habit of smoking vile black cigars. Norden resented Sperry's demand that he sign over patent rights. When Sperry proposed that arrangement in 1913, Norden quit immediately and established himself as an independent consultant. The break was personal and permanent, creating a rivalry that would shape bombsight development for decades. World War I demonstrated the destructive potential of aerial bombardment, but also its primitive inaccuracy. Pilots dropped bombs by hand, using rudimentary sights that amounted to little more than crosshairs marked on the aircraft floor. Hitting anything smaller than a city was nearly impossible. Hitting a specific building was luck. The post-war US Navy recognized that aircraft offered enormous strategic advantages for a maritime power, but only if bombs could actually hit moving ships. In January 1920, the Navy's Bureau of Ordnance contracted with Norden to improve their existing Mark III bombsight, a modified British design that required bombardiers to manually estimate wind speed, altitude effects, and aircraft velocity. The calculations were complex enough that errors were inevitable. Norden saw the fundamental problem immediately. Human estimation introduced too much variability. A bombsight needed to measure conditions directly and calculate trajectories automatically. He began work on a gyro-stabilized platform that would remain level regardless of aircraft motion, combined with a mechanical analog computer that could continuously recalculate bomb trajectory based on changing flight conditions. The technical challenges were enormous. Gyroscopes of the era were temperamental devices that drifted over time. Mechanical computers required extraordinarily precise machining to achieve the accuracy needed. Integrating these systems into a package small enough to fit in an aircraft nose required innovations in miniaturization that didn't exist yet. Norden retreated to his mother's house in Zurich in 1929 to work on the design in isolation. He emerged in 1930 with a working prototype that Navy Lieutenant Frederick Entwistle, the chief of bombsight development, immediately recognized as revolutionary. The new design, designated the Mark 15, was delivered in production quality in the summer of 1931. Initial testing demonstrated capabilities that seemed almost magical for the era. From 4,000 feet altitude, the prototype achieved a circular error probable of just 35 feet, meaning half the bombs fell within a circle of that radius. Even the latest production models of previous bombsights were achieving only 55 feet at that altitude. At higher altitudes, a series of 80 test bomb runs demonstrated a circular error probable of 75 feet. These numbers represented accuracy improvements measured in orders of magnitude. The implications were staggering. If a bombsight could reliably hit targets from 20,000 feet or higher, bombers could operate above the effective range of anti-aircraft artillery. They could attack with impunity. Precision attacks on specific factories, rail yards, and military installations would become possible, allowing strategic bombing to cripple an enemy's industrial capacity without the mass destruction of cities. The entire character of aerial warfare could be transformed. The Navy was thrilled. The Army Air Corps, when they learned of the tests, immediately demanded access to the device. Norden's company incorporated in 1928, with Theodore Barth as business partner. Barth handled production and administration, while Norden obsessed over technical perfection. The partnership worked because Barth recognized that Norden's genius came, packaged with a personality that made collaboration nearly impossible. Navy personnel called him Old Man Dynamite for his explosive temper. Contemporaries described him as self-centered, impatient, domineering, driven, abrasive, and a perfectionist with the highest ethical standards. He saw himself as a designer, not an inventor, believing only God could truly invent. His name didn't even appear on the patent for his most advanced bombsight, though he was clearly its creator. He sought anonymity and avoided publicity. The bombsight designer was never satisfied with his device. He constantly looked for improvements. When the Navy indicated they were happy with the Mark 15 and wanted to begin full production, Norden reportedly told them, "We've designed one, built one, and it works. Now we should go on to something else." The Navy persisted. They understood they possessed something unprecedented. The Army Air Corps acquired their first Norden in 1932, designating it the M1. Testing under ideal conditions continued to produce remarkable results. In April 1939, at Fort Benning, Georgia, 4 Norden-equipped B-17 flying fortresses targeted a simulated battleship 600 feet by 105 feet in size. 10 out of 12 bombs of various sizes hit the target. The demonstration was witnessed by senior military officials who came away convinced they had seen the future of warfare. The Air Corps began developing an entire strategic doctrine around the Norden and the B-17. Planners at the Air Corps Tactical School at Maxwell Field in Alabama theorized that heavily armed bombers flying in formation at high altitude could penetrate enemy airspace without fighter escort. The combination of the B-17's defensive firepower and the Norden's precision would allow small formations to destroy specific targets that crippled an enemy's capacity to wage war. Industrial centers, transportation networks, power generation. All could be systematically eliminated while minimizing civilian casualties. The doctrine was elegant, humane, and completely untested in combat conditions, but it matched American technological optimism perfectly. The United States possessed industrial capacity that could produce bombers and bomb sites in quantities no other nation could match. American precision manufacturing was the best in the world. Why wouldn't American precision bombing be equally superior? By December 1941, when the acting chief of the Bureau of Aeronautics wrote to the Secretary of the Navy, calling the Norden Bombsight the principal single factor of superiority which the air forces of this country possess over those of potential enemy countries. The entire strategic bombing apparatus of the United States rested on the assumption that the device would perform in combat exactly as it had performed in demonstrations. Security surrounding the Norden was extraordinary. The device was classified as secret, with disclosure considered a threat to national security. Workers who manufactured components at factories across the United States were sworn to secrecy and often never told what they were making. Bombardiers took oaths to protect the bomb site with their lives. General Hap Arnold insisted that bomb sites be removed from aircraft and stored in vaults under armed guard between missions. Transport to and from aircraft required escorts of 2 armed guards. The entire procedure emphasized that bombardiers carried America's most closely guarded military secret. The secrecy served multiple purposes. Obviously, preventing enemies from acquiring the technology was crucial, but the secrecy also created mystique. Rumors proliferated about the bomb site's capabilities. The public heard it could drop a bomb into a pickle barrel from 20,000 feet or 30,000 feet, depending on which version of the story circulated. The press picked up these claims and amplified them. The Norden Company itself promoted such assertions in advertising, despite knowing they were exaggerations. The truth was more complex. Under ideal conditions, clear weather, no combat stress, experienced bombardiers, targets that didn't move, no anti-aircraft fire, no evasive maneuvering, and perfect maintenance of the delicate device, the Norden could achieve accuracy within 100 feet from 10,000 feet altitude. That was genuinely impressive for the era, but ideal conditions didn't exist in combat. Production ramped up slowly. Between 1932 and 1938, the Norden Company produced only 121 bomb sites per year. The devices required extraordinarily precise manufacturing. Each bomb site contained over 2,000 individual parts, many machined to tolerances measured in thousandths of an inch. Every unit had to be hand-assembled and individually calibrated. Mass production of such complexity proved enormously difficult. When war broke out in Europe in September 1939, American war planners realized they needed bomb sites in quantities far exceeding anything Norden's small company could produce. Additional manufacturers were brought in. Victor Adding Machine Company gained a manufacturing license. Remington Rand followed. Kodak's facility in Rochester, New York, secretly manufactured optical components for the bomb site under such stringent security that workers never knew what they were making. Subcontractors were hidden behind shell companies with names that combined syllables from the founders' names. Even with expanded production, shortages continued through 1943. The bomber offensive against Germany launched before enough bomb sites existed to equip every aircraft. Lead bombers carried the Norden. Other aircraft in formations dropped their bombs when the lead bombardier released his. This formation bombing technique would become standard practice, but not for the reasons planners originally envisioned. Carl Norden never wanted fame for his creation. He considered the bomb site merely a device to help win a necessary war against fascism. After World War II, he retired immediately to Switzerland to escape the publicity. He remained religiously active and supported efforts to free clerics held behind the Iron Curtain. His son later said Norden was never proud of the bombsight as an end product. He believed the United States was the last hope of the Western world against fascism, and the bombsight was just a tool to achieve that goal. He would not have liked the fuss made about it afterward. But before the war ended, before anyone could assess whether the billion-dollar investment had been worthwhile, the bombsight had to prove itself in the one environment its creator never fully considered. Not test ranges in Virginia where targets stayed still and weather cooperated. Not demonstration flights where experienced crews had unlimited time to set up perfect runs. But in combat over Europe, where German fighters swarmed formations, where flak filled the sky with lethal fragments, where targets disappeared under clouds, where cold numbed fingers and fear clouded minds, and where the difference between hitting a target and missing it by half a mile determined whether the strategic bombing campaign would succeed or fail catastrophically. The first real test of the Norden's combat effectiveness came when the 8th Air Force began operations from England in the summer of 1942. The missions were small at first, learning operations against targets in occupied France before venturing deeper into German-defended airspace. The results were immediately troubling. Bombing accuracy that looked brilliant in tests evaporated in combat conditions. The problems were numerous and interconnected. The temperature at bombing altitude was so cold that lubricating oils in the bombsight congealed, causing mechanical failures. Optics fogged over, despite electrically heated blankets wrapped around the devices. The complexity of operation overwhelmed bombardiers dealing with combat stress. German fighters pressed attacks with such ferocity that formations couldn't maintain steady flight paths. Anti-aircraft fire forced bombers to higher altitudes, where accuracy degraded further. Weather over Europe was dramatically worse than anything experienced in training over the southwestern United States. Clouds obscured targets on more than half of all missions. Even when conditions were good, subtle factors destroyed accuracy. If a bombardier involuntarily rose from his seat as the release point approached, a common stress response, the optical path length changed enough to throw off calculations. If the aircraft slipped or skidded even slightly during the bomb run, the gyroscopic platform couldn't compensate fast enough. If wind conditions aloft differed from pre-flight forecasts, which they almost always did, the analog computer's calculations became progressively more inaccurate. By early 1943, statistical analysis revealed a devastating truth. Only 50% of American bombs were falling within a quarter mile of their targets. That wasn't precision bombing. That was barely better than random bombardment. Some missions achieved worse results. During several raids, less than 5% of bombs fell within 1,000 feet of aim points. The circular error, probable in actual combat, was averaging 1,200 feet, not 75 feet. The strategic implications were catastrophic. The entire justification for daylight precision bombing rested on the ability to hit specific targets. If bombs scattered across landscapes, missing factories by hundreds of yards, the bombing campaign couldn't accomplish its objectives. German war production would continue uninterrupted. The invasion of Europe would face fully equipped enemy forces. The loss rates among bomber crews, already terrible, would be unsustainable for no strategic gain. The crisis came to a head during the missions of August 1943. The 8th Air Force launched its most ambitious operation to date, a dual strike against ball-bearing factories in Schweinfurt and aircraft manufacturing facilities in Regensburg. These were precisely the type of targets the Norden Bombsight was designed to destroy. Specific industrial installations, whose elimination would cripple German war production. The raids would prove definitively whether precision daylight bombing could work as doctrine promised. 376 B-17 seconds took off from English bases on the morning of August 17th. The formations flew deep into German airspace without fighter escort for most of the route. Luftwaffe fighters attacked with sustained ferocity, shooting down bomber after bomber. Anti-aircraft fire over the targets was the heaviest American crews had yet encountered. Lead bombardiers struggled to maintain sight pictures through their Norden scopes, while the aircraft shuddered from nearby flak bursts and violent evasive maneuvers. When reconnaissance aircraft photographed the targets afterward, the results confirmed what crews already knew. Bombing had been scattered. Some bombs hit the Schweinfurt factories, causing moderate damage. Others fell across residential areas, rail yards, and empty fields. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Regensburg plant suffered similar results. Neither target was knocked out of production. Within weeks, both facilities were operating at near normal capacity. The cost was devastating. 60 B-17 seconds failed to return, with 600 men killed, wounded, or captured. Loss rates approached 20% for some groups. The Schweinfurt-Regensburg raid represented the collision between technological promise and physical reality that couldn't be overcome by better training or refined procedures. The Norden Bombsight was performing exactly as designed. The problem was that combat conditions made its design, assumptions impossible to meet. The bombsight required steady, level flight for several minutes during the final bomb run. But German fighter pilots had learned that attacking formations during this vulnerable phase forced bombers to break formation or take evasive action, ruining bombing accuracy. The sight required clear visibility of the target, but European weather was cloudy more than half the time, obscuring targets completely. The sight required accurate pre-flight data about wind speeds at altitude, but meteorological forecasting in 1943 couldn't predict wind conditions with sufficient precision. Most critically, the Norden required each bombardier to make an individual bombing run against the target. But German defences made that suicidal. B-17 seconds could only survive by maintaining tight defensive formations where overlapping fields of fire from dozens of machine guns kept fighters at bay. Individual bomb runs meant breaking formation, making aircraft vulnerable to attack. The bombers that tried it died. The solution emerged from necessity rather than planning. Colonel Curtis LeMay, commanding the 305th Bombardment Group, recognized that formation integrity mattered more than individual bombing accuracy. He developed the concept of lead crews. Each squadron would identify its single best bombardier and pair him with a specially selected navigator and pilot chosen for his ability to fly smoothly without sudden corrections. These lead crews would train extensively, becoming expert in every aspect of the Norden's operation. Only the lead bomber in each formation would carry out a full bombing run using the Norden. 3 other aircraft, the lead's wingman and the leaders of high and low squadrons, would also carry bomb sights in case the primary lead was shot down. Every other bomber in the formation would simply release when the lead bombardier released. Formation bombing meant accepting wider bomb dispersion patterns in exchange for keeping defensive formations intact. The 8th Air Force adopted the procedure officially in July 1943. Squadrons established formal lead crew programs. The best bombardiers received intensive additional training. They learned to operate the Norden under every possible condition. They practiced on training ranges until their accuracy approached the device's theoretical capabilities. They studied target photographs until they could identify landmarks instantly. They became, in effect, specialists operating at the peak of their profession. The automatic flight control equipment, the AFCE, became essential to the lead crew concept. This autopilot system, developed by Minneapolis Honeywell, allowed the bombardier to control the aircraft directly through the bomb sight during the bomb run. The bombardier would align the bomb sight with the target, then engage the AFCE. From that point, the autopilot maintained heading and altitude with mechanical precision that even the most skilled pilot couldn't match manually. The pilot was freed to watch for fighters and monitor formation integrity. The bombardier could focus entirely on the sight. This marriage of the Norden Bombsight and the AFCE represented the system working as originally envisioned, but only for one aircraft in each formation of dozens. Lead bombers became precious assets. Their crews flew shortened tours of duty, completing fewer missions than regular crews because their skills were too valuable to risk unnecessarily. The tail gunner position in lead bombers was often occupied by an officer pilot who monitored formation integrity and advised the lead pilot on maintaining cohesion. The first mission using the Norden and AFCE on a wide scale launched on March 18, 1943, targeting Bremen-Wegesack in Germany. The 303rd Bombardment Group, the Hells Angels, dropped 76% of its bombs within a 1,000-foot circle. That represented dramatic improvement over earlier missions, though still far short of the pickle barrel mythology. The technique worked well enough to become standard procedure across all 8th Air Force bomber groups, but well enough revealed the Norden's fundamental limitation. The bombsight could deliver extraordinary accuracy under controlled conditions with expert operators. In combat, with only lead bombardiers using it properly and everyone else dropping on their signal, it delivered adequate accuracy at best. Studies throughout 1943 showed that on average, only 50% of bombs fell within a quarter mile of targets. That was sufficient to damage large industrial complexes, but insufficient to destroy specific buildings or installations. The Air Force developed additional adaptations to compensate. Pathfinder aircraft equipped with H-2X radar led formations when clouds obscured targets, using radar returns to identify aim points. The radar couldn't match the Norden's potential accuracy, but it allowed bombing when visual conditions made the optical sight useless. By 1944, radar-aided missions accounted for more than half of all bombing operations over Europe. Missions shifted increasingly toward area bombing of large targets rather than precision attacks on specific installations. Instead of aiming at a single factory, formations would saturate entire industrial districts with hundreds of tons of bombs. The Ruhr Valley, Hamburg, Berlin, cities rather than buildings. The bombing pattern reflected reality. With circular error, probables measuring in hundreds of feet even under good conditions, attempting to hit specific structures was futile. Better to target entire complexes and accept that bombs would destroy everything within the pattern. The shift contradicted everything the Norden Bombsight was supposed to enable. The original doctrine called for precise destruction of military and industrial targets while minimizing civilian casualties. Precision weapons allowing humane warfare. Area bombing of cities was exactly what the doctrine was meant to avoid. Yet combat conditions forced adoption of tactics that the British had used in their night bombing campaign all along. The brutal truth was that the Norden Bombsight had become a justification for strategic bombing rather than a tool that made it effective. The device worked brilliantly in demonstrations that shaped pre-war planning. It worked adequately in combat when operated by expert crews under favorable conditions. But it couldn't deliver the pinpoint accuracy that doctrine required. And adapting tactics to combat realities meant abandoning the precision warfare the bombsight was supposed to enable. The Germans knew this earlier than American planners admitted. When Luftwaffe forces captured intact Norden bombsights from downed B-17 seconds in 1942, German engineers studied them thoroughly. The assessment was dismissive. The device was sophisticated but impractical for German needs. Too complex to mass-produce with too many small moving parts, too difficult to maintain in field conditions, and ultimately no more accurate than Germany's own Luftwaffe 7 bombsight when used in actual combat rather than controlled tests. German intelligence had actually acquired Norden plans before the war even started. A German spy working for Karl Norden's company copied specifications and sent them to Germany in 1938. The Luftwaffe studied the designs and concluded the device wasn't worth copying. German bombing doctrine emphasized dive bombing and tactical support for ground forces rather than high-altitude strategic bombing. The Norden's supposed advantages were irrelevant to how Germany planned to use air power. That intelligence failure, the fact that America's most closely guarded military secret wasn't actually secret, and that enemies who possessed it didn't consider it particularly valuable, revealed how much the bombsight's reputation exceeded its practical worth. The extraordinary security measures, the armed guards, the oaths, the propaganda about pickle barrels, all served to maintain mystique around a device whose combat effectiveness was ordinary rather than revolutionary. By late 1943, security classifications were reduced from secret to restricted, as officials acknowledged that hundreds of captured bombsights meant enemies knew everything worth knowing. The mystique continued in public perception, but within the military, realistic assessments replaced optimistic projections. Statistical studies documented the gap between theoretical and actual performance. Circular error probable in combat averaged 1,200 feet, not 75 feet. Accuracy was improving as crews gained experience and tactics refined, but would never approach the bombsight's potential. The final assessment came in spring 1945, as the war in Europe approached its end. By then, the 8th Air Force was putting 60% of bombs within 1,000 feet of targets under good conditions. That represented genuine improvement over 1942 and 43, achieved through better training, refined tactics, experienced crews, and numerical superiority that allowed bombers to operate with overwhelming fighter escort. But it was still area bombing of large targets rather than precision destruction of specific installations. Germany's industrial capacity had been devastated. The Ruhr was shattered, transportation networks collapsed, oil production crippled, cities burned, but this destruction resulted from sustained application of overwhelming force rather than precision strikes enabled by superior technology. The British achieved similar results with night bombing, using simpler bombsights but larger tonnages. The Americans had better bombsights but flew daylight missions that exposed crews to higher losses. The end result was comparable destruction achieved through different means. Nearly 90,000 Norden bombsights were built during the war at a total program cost of $1.1 billion. That was 2/3 of the Manhattan Project's cost, or more than 1/4 of the production cost of all B-17 bombers. The investment bought a device that worked as advertised under specific conditions but couldn't overcome the fundamental challenges of combat bombing. It bought doctrine that looked elegant in planning but proved inadequate in practice. And it bought mystique that sustained morale and justified strategic choices, even after reality demonstrated the limitations. Carl Norden died in 1965, long after the bombsight's limitations were documented, but while its legendary reputation persisted in popular imagination. He never spoke publicly about whether the device achieved what he'd intended. His son reported that Norden considered himself a designer solving technical problems, not an inventor creating world-changing weapons. He'd been asked to build a bombsight that improved on existing devices. He built one that did exactly that. Whether it could deliver on the promises made by others wasn't his concern. The Norden continued in military service through the Korean War and into Vietnam, used in B-29 superfortresses and B-52 stratofortresses. A specially modified Norden bombsight was used to drop atomic bombs on Hiroshima and Nagasaki in August 1945 from the B-29 Enola Gay. That bombsight is now on display at the National Air and Space Museum in Washington, D.C., a reminder that the device's most historically significant use came in missions where its precision wasn't actually necessary. The nuclear weapons would have devastated their targets, even with substantial aiming errors. The bombsight's legacy extends beyond its combat record. It represented a distinctly American approach to warfare, the belief that technological superiority could substitute for mass and brutality. That precision weapons could make war more humane by allowing destruction of military targets while sparing civilians. That innovation and engineering excellence mattered more than numbers and endurance. All of these assumptions shaped American military doctrine for the next 80 years. Modern precision-guided munitions realize what the Norden promised but couldn't deliver. Laser-guided bombs, GPS-guided joint direct attack munitions, cruise missiles with inertial navigation. These weapons achieve accuracies measured in feet rather than hundreds of feet, and do so reliably in combat conditions rather than just demonstrations. The principle remains identical to the Norden's design: measure conditions continuously, calculate trajectories in real time, adjust for changing factors, and guide the weapon to its target. The execution simply required computer technology that didn't exist in 1943. The bombardiers who flew combat missions with the Norden, who watched their bombs miss targets by hundreds of yards despite doing everything correctly, who understood that the device couldn't deliver what propaganda promised, deserve recognition for completing an impossible mission. They flew into flak and fighters with equipment that worked brilliantly in theory but adequately at best in practice. They achieved results that helped win the war not through revolutionary accuracy, but through sustained effort with available tools. The engineers who designed and built 90,000 precision instruments during wartime, who solved extraordinarily difficult manufacturing challenges, who created mechanical analog computers that represented the state-of-the-art in computing technology, demonstrated capabilities that shaped post-war electronics and aerospace industries. The techniques developed for mass-producing precision mechanisms at scale enabled the technology boom that followed. The planners who built doctrine around the Norden's promise, who believed that American technology could transform warfare, who invested billions in a system that delivered less than hoped, learned lessons about the gap between laboratory performance and battlefield reality. Those lessons influenced military procurement and doctrine development for generations, teaching skepticism about revolutionary weapon claims and emphasis on field testing under realistic conditions. The gap between the Norden bombsight's reputation and its combat effectiveness reveals something fundamental about how nations fight wars. Technology matters, innovation provides advantages, but capability under ideal conditions predicts very little about performance in the chaos of combat. The Norden could put bombs in barrels during demonstrations. In combat, it helped bombardiers hit general target areas, often enough to contribute to Allied victory. That was sufficient, barely, but it wasn't revolutionary. The story of the Norden is not really a story about a bombsight. It's a story about the collision between American technological optimism and the messy reality of industrial warfare, about the distance between what engineers promise and what soldiers can deliver, about doctrine built on assumptions that combat conditions make impossible, and about the persistent gap between weapons that work in tests and weapons that work in war. That lesson, learned at enormous cost over the skies of Europe between 1942 and 1945, remains relevant today. Every revolutionary weapon system, every promise of precision that will make war more humane, every claim of technological advantage that will substitute for difficult strategic choices, echoes the promises made about the Norden bombsight. Some of those promises will be kept. Others will dissolve in contact with reality. The challenge is knowing which is which before billions are invested and lives wagered on capabilities that exist only under ideal conditions. The B-17 seconds that carried Norden bombsights to targets across Europe represented the most sophisticated bomber-bombsight combination of the war. Together, they achieved results that helped destroy Nazi Germany's capacity to fight, but those results came through sustained application of massive force rather than revolutionary precision. The bombsight worked well enough when everything else worked, which was rarely, and well enough had to suffice, because it was all that technology and conditions allowed. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.